All right, so we're going to talk about the recent quiz and kind of some things that we should look at in order to do our retake. So let me hold on, zoom out of this. All right, there we go. All right, so number one is we're going to review independent and dependent variables, creating a function and solving the problem handed to us. So there we go. All right. So number one, you are doing chores to earn your allowance. For each chore you do, you earn $3. How much money will you earn after completing 11 chores? So independent and dependent variable. The independent variable is something that you can control that will affect something else, right? And the dependent variable is the one that's affected by that. So in this case, we're doing chores and we're earning allowance. So our two variables are the number of chores that we do and the total allowance we earn, right? It goes that if we do more chores, we earn more allowance. So our independent variable is something we would control, something that will affect an outcome. And in this case, that's the number of chores that we do. The more chores we do, the more money we make. And that is the dependent variable because the amount of money we make is affected by the number of chores that we do. So money earned is our dependent variable. The money we make or the money we earn depends on the number of chores that we do. Now our function in this example, we have to kind of read further in, right? You do a chore, you earn $3. Okay, so basically this is saying that we make $3 per chore. Well, I gotta move this kind of in my way. Hopefully it's not too bad. All right, $3 per chore. So remember, independent variables are x variable, and that's number of chores. So if we're earning $3 per chore, we're doing 3 times x, right? That's $3 per chore. Some cases you want to think of it, instead of using x, if you want to use c, that's fine. F of c equals 3 times c, because it's $3 per chore, right? Every chore you do, you earn $3. So if you did 5 chores, $3 for each of them, that would be $15 altogether, right? Multiplying those values to get your total. So our function is f of x equals 3x, or if you want to use c, that's fine as well. F of c equals 3c. But now we're going to find the solution. So we read on even further, right? How much money will you earn after completing 11 chores? So you just made this function for a reason because now you're going to use it, right? Now we're talking about 11 chores. So now we're talking about plugging in 11 for our c value or whatever variable we use. It could be x if you want to leave it as x, right? So f of 11, this is not a math problem right here. This is just saying, hey, your function, you're plugging in 11. We have 3 times 11, right? 3 times, because we're plugging in 11 for c, right? So 3 times 11, which means $33. If we did 11 chores at $3 per chore, we would make $33. So now let's look at number 2. Number 2 is pretty much the same problem. If you want to pause the video and try it yourself, go for it, and then you can check your answer. Or you can just watch through if you're still a little bit confused. So Ronaldo's a car salesman at a local dealership and earns $500 each week plus $100 per car that he sells. If Ronaldo sells 8 cars for the week, how much money will he make? Okay, so let's focus our first part of this, right, just in the beginning, right? We're a car salesman. Ronaldo's a car salesman at a dealership, and he makes money per car that he sells. So the independent dependent variable here is what Ricardo has control of, right? And then what that's affected by. Ricardo can control how many cars he sells, right? The number of cars that he sells will affect how much money he makes. So right there are the two variables, are independent and are dependent. Ronaldo can control the number of cars he sells, right? And this will affect how much money he makes, right? This is the independent variable because it's something that will affect something else. The dependent variable is going to be the money made because it's it's affected by the number of cars that he sells, right? If he sells fewer cars, he makes less money. If he sells more cars, he makes more money. So the amount of money he makes is depending on how many cars he sells. Now our function here, I'm going to say f of c, and I'm going to use c for cars, but again, you can use f of x, whatever variable you want. It's all good. Our function is, how much money we're talking about. We're talking about how much money Ronaldo makes at his job. So he earns $500 each week. So he's earning $500 up front. And then he's adding an additional, right, plus an additional $100 per car. So he's adding $100 per car, right? That per car tells you exactly where your variable is going to go. That's saying 100 times C. Or X, again, if you used X, that's fine. I just used C in this case, so I'm just going to stick with C. But there it is, right? It's $500 each week plus the $100 per car. Now, one thing that confuses some students is 500 each week. Sometimes they think, oh, it sounds like 500 per week, meaning it should be like 500X or something like that, or 500W, but that's not the case because our variables are not about weeks, right? Our variables, as we look back over here, are about the number of cars we sell and the amount of money we make. It has nothing to do with the number of weeks we sell cars, right? If it was a number of weeks we sell cars, that'd be different. But it's not. It's just the number of cars that we sell. So we're really only talking about his paycheck in 1 week's period of time, and that's it. So he'd make $500 just for working at his job, and then $100 for each car. So there's our function. Now we're going to use that function to answer the last part of this question. If Ronaldo sells 8 cars for the week, how much money will he make? So f of 8, plug in 8. Remember, this is just saying we're evaluating the function at 8. It really doesn't do anything else. Right, we're going to plug 8 into our function. 500 plus 100 times 8. So remember, you're selling 8 cars, $100 per car. So that's going to be $800 right there in all the car sales you make. And then an additional $500 from your job. And that comes out to a total of $1,300. Oh, there you go. All right. Number 3, write a function in function notation and identify a reasonable domain and range for the function. So our function, f of, I'm going to write f of t, but let's read the problem first. Mark has already sold $72 worth of tickets to the concert. He has 7 tickets left to sell at $8 per ticket. So our function is about how much money Mark is earning, right? How much money Mark's make. So I'm going to use t for tickets here, f of t equals, and now again, it's all about how much money Mark makes, right? He already has $72, right? He's already made $72. So that's not going to go away. He's got $72. But he can add to that total if he sells $8 per ticket, right? So $8 per ticket, that's 8 times t. So he has $72, but he can add $8 for every additional ticket he sells. So our function is 72 plus 8t. Now, domain refers to the number we skipped. He has 7 tickets left to sell. This is all about our domain here. Our domain is numbers that we can use for t or x, but we're using t in this case, right? It's our input values. And since we only have 7 tickets left to sell, then we can only sell a whole number of tickets up to 7, right? So these are all the possibilities, right? We could sell 0 tickets, right? We might go the rest of the day without selling any tickets. We might sell 1 ticket. We might sell 2 or 3 or 4, 5, 6, or 7, right? But I can't sell any more than 7 because that's my limit, right? I'm limited to 7 tickets. I can only sell up to 7 more tickets because that's all I have left. So I might only sell 1, I might only sell 2, I might only sell 3, but these are all the possibilities, right, of what might happen at the end of the day. I might sell 0 tickets, I might sell only 1 more, 2 more, etc., right? But I can only sell up to 7. All right, and my range, so again, this is my domain, this is tickets to sell. My range is my money, right? My range is my money, the money that Mark makes from selling his tickets. Now, if Mark didn't sell a single ticket more, right, he would still have $72, right? Because essentially, if you sell 0 tickets at $8 a ticket, right, you're not making any more money, but you still have, or Mark still has, the $72 from earlier in the day. If he sells 1 more ticket, he'll add $8 to his total of 72, meaning that he would have $80. If he sold another ticket, if he sold a second ticket, he would add another $8, which would be $88, right? So this is if he sold 0 tickets, if he sold 1 more ticket, if he sold 2 more tickets, and we have to do this until he sells 7 tickets. So if he sold the third ticket, that would be $96. If he sold the fourth ticket, it would be $104. If he sold a fifth ticket, it would be $112. If he sold the sixth ticket, it would be $120. And if he sold one more ticket, he would have $128. So essentially, these are the same thing as if you just plugged these x values or these t values into the function, right? If you want to know how much money he makes after selling 6 more tickets, you would just do 8 times 6, right? But that's ultimately going to be 120, as I mentioned. So since I know I'm just counting up, every ticket I sell, I make another $8, right? Because it's $8 per ticket. That's why every time I went up 1 here, I just added 8. Because if I sold another ticket, I would make another $8. But it still follows this function. It's still connected to that function. If I sold 2 more tickets, right, I would add $16 to my 72 already, and that is $88, right? So these are connected. It's still related to that function. I just thought it would be easier just to count up by 8 every time successively. All right, now number 4, graphing the function. So we have a function that's 2x minus 1, and here's our domain. The thing to keep in mind is that the domain is our x values. So what that means is that we will plug these numbers in for x, right? We'll start with -2. What I really encourage you to do is make a table, right? Make a table so that you understand what your ordered pairs are. So our x values are given to us, right? It's -2, it's 0, it's 1, and it's 4. Because that's the domain. Those are the x values that were given. So what we're going to do is we're going to plug those into the function one at a time and see what the outputs are for each of them. So if I plug -2 in, then this function is 2 times -2 minus 1. So what that means is 2 times -2 is -4, and -4 minus 1 is -5. So my output would be -5 when I plug in -2. Now, if I plug in, this isn't erasing for me for some reason. There we go. If I plug in, what's the next number? 0. If I plug 0 in, 2 times 0 is 0, and 0 minus 1 makes -1. So my output would be -1 for plugging in 0. I'll plug in number 1. 2 times 1 minus 1. 2 times 1 is 2, and 2 minus 1 makes 1 overall, so 1 is the output for that. And then lastly, we plug in 4. 2 times 4 minus 1. 2 times 4 is 8. 8 minus 1 makes 7. So now I've got 4 points that I can plot on my graph. So the first one's -2, -5. Now notice that our graph is going by 2s every time. So if it makes it easier, let me zoom in on this. If it makes it easier, let's label it, right? That's -2. This would be -6. And I put these little hash marks. Let me redo it. Put these little hash marks where the odd numbers will go, like -1, -3, -5, -7, -9, and so on. I'm going to do that for the rest of these. So that'd be -2. This would be -6. These would be the odd numbers. That'd be 2, 6, and again, these would be the odd numbers. Again, that's 2, that's 6. These would be the odd numbers. Okay, so that might help us. -2, -5. -2, -5 would be right here. That's -2 on the x-axis and -5 on the y-axis. All right, 0, -1. 0, -1 will be right here. Hopefully you can see where I'm putting that point. I'm trying to make it obvious. 1, 1 will be right here. And 4, 7 will be up here. All right. So hopefully you can see those okay. Things to keep in mind, even if you end up graphing this wrong. Let's say you put your points here and your points are just in the wrong places, right? I can still give you partial credit with this table. So make sure you write a table so that I know that you've done the majority of the math right, that you were able to plug in these x values into the function and get out those y values. You might have graphed it wrong, so you might lose a point, but overall, make sure that you're showing your work. Make sure you write out that table so that I know what points you intended to graph in case you do graph it wrong. Now, it's also worth mentioning that there is no line on this graph, okay? There's no line, there's only points. We're only allowed to graph these points. And why that is because our domain was limited to only those 4 points. When you draw a line, you're saying the domain is continuous. instead of discrete, which means discrete's only these points, whereas continuous would be that line. So only graph those points when the domain is discrete. And now number 5, we're going to do the same thing for number 5. We're going to create a table, help us out. But the thing is, it doesn't give us a domain here. It doesn't say any numbers to plug in. So in that case, what we get is the option to plug in. We get to pick the numbers for X to plug in. And since our domain is not limited, once we plot our few points, then we'll be able to draw a line through those points, because all we're trying to do essentially is plot some points to see what the layout of the graph looks like. And then once we see the layout of the graph, we'll draw our line so that we can complete our graph. So values to pick, you can pick anything you want, but generally you want to pick numbers that are some negative, some positive, and consistent. So almost a foolproof go-to, something that a lot of students you can just use all the time, are like -3, -2, -1, 0, 1, 2, and 3. That might look like a lot, but the more you can plot on your graph, the better. And the reason that these are a good set of numbers to choose is because it picks some negative numbers and it picks some positive numbers, but also it keeps it consistent. You're not going from, -3 to like 5 and 7. You're not like jumping around, right? Everything here is kind of in a neat order, right? They're always going up by 1. So I'm not like hopping around. I'm keeping my numbers consistent. All right, but now we do the same thing that we did in the last problem, which is just plug these numbers in. So when you plug these numbers in, for example, when we plug -3 in for X over here, what that's going to look like is -3 squared minus 2. Now, something to keep in mind, I'm going to have to open my calculator, so give it a second to show up. If you're going to use a calculator to help you do this, make sure you use parentheses when you're asked to square something. I'm going to show you why here in a second. So let's close that. So when I type -3 squared in and I don't use parentheses, it's going to give me the wrong number. It's going to give me -9. That's incorrect. Now, just to prove it's incorrect, remember what -3 squared means. -3 to the second power means -3 times itself, -3, right? So that's what -3 squared is supposed to do. It's supposed to multiply it by itself, which means your answer should be a +9, not a negative. So how do you avoid that? Well, if you use parentheses when you plug in your negative number, right, and then you square it on the outside of the parentheses, this will calculate it correctly the way you're asking it to, so that it will give you the right number. So when I'm plotting this point, right, I'm trying to graph this function, -3 squared minus 2. I'm going to make sure I do -3 squared, right? I'm going to just type it over from the beginning, -3 to the second power, right, minus 2, and my outcome is 7. And so that gives me immediately my y value, which is 7. All right, and then we can do that continuously by plugging in different numbers, right? Next number I'd plug in is -2. And if I'm using a calculator, I'd do the same thing, right? Use parentheses to plug in my number and continue to evaluate. So my output would be 2 for that point, right? And so on and so forth. Now, you're still able to do this in your head, though. You shouldn't rely on a calculator, because if you want to do -2 squared minus 2 without a calculator, just keep in mind it's just -2 times itself, -2, which is a +4, and then subtract 2. +4 minus 2 is 2, which is how we get that answer. So let's do the rest of these without a calculator. I just wanted to show you that in case you do use a calculator, so that you're not getting the wrong answer. If you plug -1 in, -1 squared means -1 times itself, -1, which means you have +1. And 1 minus 2 leaves you with the answer -1. So now let's plug in 0. When you plug 0 in, you're doing 0 squared, which remember is 0 by times itself. 0 times 0 is still 0, and when you subtract 2, 0 minus 2 is -2. When we plug 1 in, we'll have 1 squared, which means 1 multiplied by itself. 1 times 1 is 1, and so 1 minus 2 is -1. Again, you plug in 2, you're doing 2 squared, that's 2 times itself, 2 times 2, which makes 4, and then 4 minus 2 makes 2. And then one more number, we'll plug in 3. When you plug 3 in, you're doing 3 squared, which is 3 times itself, which is 9, and then subtracting 2. 9 minus 2 is 7. And we're going to plot these points. So what I've done is I've got some points of what will be on my graph, and hoping that when I plot this, I can see the pattern and get an idea of what the graph looks like. So let me do the same thing I did on the last one, which is kind of put these little hash marks, help me graph it. Okay, that one messed up. There we go. So -3, +7 will be right here. -2, +2 will be here. -1, -1 will be right there, right on top of that. 0, 0, -2 will be right there. Hopefully, again, you can see that. 2, no, wait, I forgot. 1, -1 would be here. We have 2, +2 here, and then we have 3, 7, which is there. All right, so I can see what my graph is doing, right? I can see that it's a U shape. So now that I can tell the pattern of it, I'm going to connect these points with my line to complete my graph. So remember, here's the difference between these two problems. The one on the left does not get aligned because the domain was limited to just those 4 values, right? So we're only supposed to graph at those 4 points and those 4 points only. Number 5, it did not give us a domain, which means we're asked to graph the entire function, not just specific points. But in order to do that, we have to plot a few specific points so that we can see what the function is shaped like. Once we know what it's shaped like, then we can completely draw our function with a line. And then one more question, number 6. The fastest recorded Hawaiian lava flow moved at an average speed of 3 miles per hour. The function f of x equals 3x describes the distance of lava moved on average in x hours. Graph the function. Use the graph to estimate how many miles the lava flowed or the lava moved after 6.5 hours. So we already have a function, f of x equals 3x. In order to graph it, what we should do is make a table, come up with some values to plot on the graph, kind of just like we did in number 5. Plot those values so we can see the shape of the graph. Now, it doesn't make any sense to use negative numbers here, like, -3, -2, -1, 0, 1, 2, 3. It would be silly to use those numbers because if you look, our domain is only positive, right? Because remember, x is about hours, right? It's the hours of lava flow. There's no negative hours. So what we're going to do is we can pick numbers. Let's pick numbers starting at 0 and work our way up, right? Let's start with 0. Let's go 1, 2, 3, 4. Let's start with that, and we can try to do a few more. Let's try to do 5, 6, 7. Let's try to get that many. Really, the more we can do, the better. So don't be lazy. The more you can do, the better. So if we plug 0 in, that would be 3 times 0, and that answer is 0. If we plug 1 in, it's 3 times 1, which is 3. If we plug 2 in, it's 3 times 2, which is 6. 3 times 3 makes 9. 3 times 4 makes 12. 3 times 5 makes 15. 3 times 6 makes 18. 3 times 7 makes 21. So now I've got some points. Let's graph them. So this graph's going to be kind of tough, but we'll manage. So 0, 0. 1, 3 is kind of tough. So keep in mind this is going to be 5, 15, 25, 35. So 3 is going to be a little bit below 5, so it's something like there. Then we had 2, 6, so it's going to be right above 5, so about here. We had 3, 9, so it'll be just below 10. We had 4, 12, so it'll be just a little bit above 10. 5, 15, so 5, 15 is going to be right on that spot. 6, 18, again, kind of guessing where 18 is, just between 15 and 20. 7, 21, so just a little bit above the 20. Right, and if I want to graph 8, 8 would be 824. 9 would be 927, right? So we've got several points. So we can tell that our graph is just a line that's increasing upwards. Now let's use that graph to answer this question about the lava flow in 6.5 hours. Well, 6.5 hours would be right in between 6 and 7, should be right here, right? And if I trace this up to my function, it looks like it hits right about there, which is kind of right between, remember this was 18 and this is 21. So it's probably just a little bit above 18, a little bit below 21. So something close to, something close to 19, 20-ish, something like that, right? So about 19, right, is our answer. Now, if you actually type this in the calculator, if you actually do plug the 6.5 in for x, remember our function was 3 times x. If you actually plug it in, this ends up being 19.5, which, of course, our estimate of 19 is really close then. It's really accurate because, we judged based on our graph, it looked like it was just about 19. So that's good. Now, our graph, again, is just a sketch, so it's not going to be perfect. But yeah, that's essentially how you'd graph it and how you'd use that graph to estimate the 6.5 hours. You could also estimate other times, right? For example, if you were to guess 3.5 hours, 3.5 hours would be right here, which is about 10, right? It looks like it's about 10. I think technically it's 10.5, but 10 close enough, right? So it's an estimate of where it is about. So that's everything from the quiz review. So we're gonna do a retake next week. This is your study guide. If you have any questions, be sure to let me know. See you guys next week. Have a good weekend. Bye.